Hi, Dr. Godes.
Hey Tyler, welcome to the post-class recap on solubility in an acid base. And it seemed like students were having a little difficulty using the solubility rules to predict solubility, when something is going to be dissolved in aqueous solution or when it's going to form a solid. And so I thought we could maybe talk a little bit about it and then go through a few examples. So partly what I wanted to say was that this isn't just a random set of rules. There's organization to this set of rules, right? It's split into three sections. There's this top section, there's this middle section, and there's this bottom section. So if we look at the top section, what defines the top section? Well, it's that everything up here is soluble. Everything up here is soluble. So if you ever see NH4 in an ionic compound, what does that mean, Tyler?
If you see NH4 in a compound, that means it's going to be soluble no matter what.
No matter what. No matter what its partner. If you see nitrate, NO3, soluble. If you see acetate, soluble. If you see a group 1 ion, the alkali metals, always soluble. And in fact, there's another name that we could give to these. Turns out, hint hint, these are all going to be spectators. That's actually a really good list of spectator ions. Pretty much they're always going to be spectators. Now this middle section, this is for things that tend to be one thing, but there are exceptions to it, right? So compounds containing the following anions are soluble except as noted. Halides. Halides are soluble except if they're paired with one of these. That's not that many to remember, right? There's 4 exceptions. SO4 2-, sulfate. They're soluble except when they're with these. Right? So mainly soluble, but some exceptions.
Always soluble.
Always soluble. And then down at the bottom, what does it say?
All the other compounds are insoluble.
Okay, so everything else insoluble, but then there are a couple exceptions as well. Barium hydroxide, calcium hydroxide, strontium hydroxide are soluble, right? Those are exceptions to that. Right? So are oxides going to be soluble or insoluble?
Oxides are going to be insoluble.
Insoluble. Sulfides, insoluble. Carbonates, insoluble. Phosphates, insoluble. Right? Anything that's not up here, it's going to be insoluble.
Right.
And so we have a few examples over here of compounds, and let's use the rules to determine whether they're soluble or not. So, manganese 2 nitrate. I know that that's manganese 2 because I know nitrate has -1 charge.
Right.
To balance it, it's got to be manganese 2. Soluble or insoluble?
All nitrates are soluble.
All nitrates are soluble, so that's soluble.
Whew, let's get it wrong. All right.
Sodium sulfite, right? I recognize SO3 as the sulfite ion.
Right. But once we see the sodium here, we remember that sodium is always soluble.
Always soluble. Okay. Copper 2 chloride. Again, I know that's copper 2 because chloride has a -1 charge when it's the ionic form. That means that has to be copper 2 to balance it. So what did we learn about halides?
Halides are always soluble.
Halides are always soluble, but that was in the middle section, so there are exceptions. And so you ask yourself, is this one of the exceptions? Well, one of the exceptions was Cu plus 1. Well, is this Cu plus 1?
No.
No. So that means that this is not one of the exceptions. That means it's soluble.
Okay.
Okay. Lead 2 sulfate. Sulfate's 2-. That means the lead has to be in the 2+ state.
Right.
The table says sulfates are soluble, except for a few cases. Is this one of the exceptions?
Yes.
Yes. So sulfate's soluble, but this is an exception, so that means it is
Insoluble.
insoluble.
But we need to be really careful with the exceptions because in this case, a majority of them are soluble, right?
Right.
The exception was that it was insoluble.
Right.
Okay.
So lead was the exception, that made it insoluble. Up here, the halides, they're soluble, and so we checked, is that ion one of the exceptions? And we have to be really careful about it because copper is an exception, but it's the copper 1 that's an exception, not the copper 2. And so if I had had copper 1 chloride, CuCl, so a different ratio, it's a different identity,
Right.
this would be insoluble. But copper 2 chloride is soluble. Right? So the charge really makes a difference on the properties of the compounds. So pay attention to charges. The last example, let me see, carbonate is 2 minus, so that's, I think, chromium 3 carbonate. Well, carbonate didn't show up anywhere on the table, neither did chromium, and so this falls in that last category, everything else. Everything else is insoluble. Is this one of the exceptions, one of those hydroxides? No, it's not, and so that is insoluble.
Right. So make sure you keep track of your exceptions and remember what they're an exception to, if everything else is soluble or if everything else is insoluble. Because it depends, depending on what rule it is.
Right, and which one you say first, soluble or insoluble, or
Right.
insoluble, soluble.
Yeah.
And it gets a little confusing because the words are kind of similar. So the other topic of the day was acid-base chemistry. And so what I've written up here is kind of a generic symbolic acid-base reaction. And so HA stands for the acid, B stands for the base. And what's happening in this reaction, Tyler?
Well, in this reaction, it looks like the proton gets donated from the acid to the base.
Okay, so all that's really happening is this hydrogen is moving from the acid to the base, and it's moving as an H plus. Right? So H plus leaves HA, that leaves behind a negative charge. H plus moves onto B, that creates a positive charge. Now, of course, if this started with a negative charge, for example, hydroxide, when you add a positive charge to the negative, they cancel and you get a neutral compound. Right? So you have to pay attention to the charges that you're starting with. Bottom line is you're moving an H plus from one thing to another.
Right.
So it seemed like most of you were moving through this pretty well. The only other thing that maybe I want to say at this point is one word, and that's memorize. You need to memorize the list of strong acids. Hydrochloric acid, hydrobromic acid, sulfuric acid. There were, I think, 7 different acids we want you to memorize. That way, you see it in a chemical reaction, you'll recognize, oh, that's an acid. It's probably going to do a simple reaction, like move a hydrogen from one thing onto another thing. I think that's about it for today.
All right.
So a little shorter than normal, but that's good, right? Meant that you guys kind of got what was going on today.